Okay, ladies and gentlemen, what we're doing now is we're solving a linear system of 3 variables. So this just builds upon solving a linear system of 2 variables. And the very first thing that we did when solving a system of 2 variables was to see if a given ordered pair was a solution to the system. Well, in this particular case, in solving a system of 3 variables, we don't have an ordered pair. We have what's known as an ordered triple. Okay? The first number in your ordered triple will stand for your x variable. The second number will stand for your y variable. The third number will stand for your z variable. Notice I make my z's with a line through them as to distinguish them from a 2, because some people can't see the difference. Okay, so what do we do here? What's the idea? The idea is to show that when x is -1 and when y is 2 and when z is -2, all 3 of those equations in the system are true. So how do we verify it? What do? We just simply plug it in. Exactly. So here's what we're going to do. I'm going to divvy this up by group. So we have to check to make sure that when we plug in -1 plus 2 times the value of y, which was 2, minus 3 times the value of y, which was -2, that it indeed equals 9. I want the left-hand side. I want all you guys over here to check that to make sure that that's true. Okay, the middle one is this one here. This is going to be the 2 rows in the back. The whole 2 rows in the back, you girls, and the 3 fellows over there are going to check to make sure that 2 times -1 minus 2 plus 2 times z is a value of -2 is indeed worth -8. So you guys in the back 2 rows do that. Ladies up front, you verify for us that the bottom equation, when you plug in when x is -1, so the negative of -1, plus 3 times 2, minus 4 times -2 is indeed worth 15. Okay, so you girls check that to make sure that that's true. And we'll come back. According to all the individual groups here, we have checked and we've independently verified that indeed 9 is equal to 9, and that -8 is equal to a -8. And that a 15 is equal to a 15. So you actually have to check each of these to show that they are indeed true. Is that pretty straightforward so far? Yeah. All right. The second idea that we're going to talk about here is the strategy to solve a 3x3, or 3 variables with 3 unknowns is what they call it. Now, this strategy is called the elimination method, but really it's just an extension of the addition method. Okay? If you read the book, and I'm sure all of you are skimming the book every single night, if you read the book, there's like a 6-step process for how to solve these types of equations, or these types of systems, excuse me. But you don't need 6 steps. What you just need is an overall strategy to do it, and here is how you do it. I'm going to teach it to you right now, okay? Your first goal is to pick one of the variables, either the x, the y, or the z, and eliminate one of the variables from 2 of the equations. So what do I mean by that? Is, let's say the top equation is called the top equation, the middle equation is called the middle, and the bottom one's called the bottom. So we have top, middle, and bottom. So which variable, either x, y, or z, which variable would be easiest to eliminate? Z. Okay, z is a good choice. Now, can you explain why z is a good choice? Absolutely. I think you guys are right on track here. So here we go. So what we're going to do, this is how I show you this. The goal, this is the plan. We are going to eliminate the variable z from the top and the middle. Okay? That's what we're going to do first. So what is it going to take to eliminate the z from the top and the middle? Multiply the middle row by what value? 2. By 2. So I'm going to go ahead and put parentheses here around the whole thing and multiply this whole thing by 2. Okay, I'm going to make this a little smaller so we can all see and give ourselves lots of room to work. So if I do this, then here's what I'm going to get. Okay, I'm going to write this in blue for us over here. I'm going to leave the top equation alone, so 5x minus 2y minus 4z is equal to 3. So we do nothing to the top equation. The middle equation we multiply by 2, and we end up with this. We end up with 6x plus 6y plus 4z is equal to -6. Check my math, make sure that that's correct. You guys on board? Yes. All right, good. Now, when we really add these together, right, this is the addition method working for us. Notice the z is going to be eliminated. So I'm going to get 11x.
Yeah.
All right. I'm going to get a positive 4y. And I'm going to get on the other side a negative 3. Does that work?
Yes.
Good. I'm just going to keep that off to the side right now. So far, so good. We have chosen a variable, and we have eliminated it from 2 of the 3 equations. You guys get that? That's the first idea. The next step, once you've done this, is to eliminate the same variable, and in this case it's z, from 2 other equations. And the reason that we do this is because we're going to end up with another equation that only has an x and a y in it. Otherwise, if we chose to eliminate z again from the top and the middle, we'd end up right back where we started. And if we chose to eliminate a different variable, we wouldn't advance ourselves. We'd still be stuck with an equation that has 3 unknowns. So the deal is we choose the same variable and we eliminate it from 2 different equations. So which ones do you guys want to do? You can either do the top and the bottom or the middle and the bottom, and it doesn't matter to me. It doesn't matter which one we choose because ultimately it's going to work out the same. So think about it right now. Okay, so after a great discussion, we think that we're going to eliminate from the middle and the bottom. Okay, sweet. So again, I'm going to write down what I'm doing. We are going to eliminate z again from the middle and the bottom. Okay, awesome. So that's my little game plan. Okay, now ask yourself this. What is it going to take to eliminate z from the middle and the bottom?
Multiply the middle by 3 and the bottom by 2.
Kenan says to multiply the middle one by what?
3.
By 3. Okay, so I'm just going to go ahead and replace that with a 3. And multiply the bottom one by what?
-2.
And I'll do this in pink over here so we can see the difference by a -2. Do we agree with Kenan's move there?
Yeah.
We do agree. Okay, so let's go ahead and do that. I'll move this up so we can see what we're doing. And I'll do this all in, I think, this green color. Okay, so I'm going to get this. I'm going to get 9x plus 9y plus 6z is equal to -9. Did I do that correctly? Awesome. Next one down below, I'm going to get a positive 4x. I'm going to get a negative 10y. And I'm going to get a negative 6z. And that's going to be worth a -6. Everybody see where that came from? Beautiful. And again, we're going to do the addition method. So 9 and 4, so I'm getting like 13x, minus y is now equal to a -15. Is that what you guys are getting too? Did I get the same thing you got? Okay, check it out, you guys. Now, we have an equation. We have a new system. Look how beautiful this looks. I have a new system that only has x's and y's. Look, I have 11x. Plus 4y was now worth -3. And I have 13. I have 13x minus y is equal to a -15. Beautiful. Okay, great. Now I'm back to section 7.1. Right. So we can choose to eliminate the x or the y. Doesn't matter. What do you guys want to do? Ooh. Okay, let's do that. She's adamant. We're going to do this. Let's multiply this one by 4 and then add them together. I think it's a really good move. So that's going to give me this. 11x plus 4y is equal to a -3. So your 4 13s is 40 and 12, so is that 52? Is that right? So 52x minus 4y is worth, was that -60? Sweet. And again, we're just going to add these up. So I'm getting 63x is now worth a -63. Hey, check this out. Did I say I'm getting that x is worth -1? Hey, that was really nice. That turned out to be really nice. Oh, you're very welcome. What do we do now?
You have to plug it into one of the equations with just x and y.
Exactly. From now, this is called back substitution, right? So we take our -1 and we can plug it anywhere for x that we want to, and we start working our way back. Okay.
Be the same number if you plug it in.
Yep. Doesn't matter. That's the cool thing about it. If it's a solution, it'll work for any of them that you choose.
Just like, is it a solution? Make us plug it in.
Right. So now here we go. I got 13 times -1 minus y is worth -15. So negative 13 minus y is worth negative 15. So y is worth how much? What do you guys get with that? Y is worth 2. Very good. Y is worth a value of 2. Awesome. So now I know x is worth negative 1, y is worth 2. And then lastly, what am I going to do?
Plug it in.
Exactly. I'm going to go. I can choose any one that I want. It doesn't matter. So I have to go back to my original because I need a z, right? So I'll go ahead and choose the top one. No big deal. All right, I'll bring it way over here. I'm going to need some help. I don't remember what this is. So 5. What was the value of x, you guys? Negative 1. Thank you. Minus 2. Minus 2. What was y again? Y was 2. Thank you very much. Appreciate it. And then minus 4z is equal to 3. Okay, perfect. So this is negative 5. This is a negative 4. This is minus 4z, and that's a 3. So it looks like negative 9 minus 4z is worth 3. So negative 4z is worth 12. Beautiful. So z is worth negative 3. So ladies and gentlemen, the answer that I'm looking for here is the ordered triple of negative 1, 2, and negative 3. Bless you. And check it out. There's the whole problem, start to finish. So here's our third and final one for this particular lesson. Now, there's something really nice about this particular one. And does anyone see it right away?
We already have.
Well, yeah, the x's are all x's. That's true. But what
All
about?
you have to do is,
already have one too.
Very good, guys in the back. Everyone realize that the top equation is already missing a y. That's beautiful. There you go. So a good strategy for us to use in this particular case would be to eliminate which variable? Very good. Let's eliminate the y variable from the middle and the bottom. So there's my game plan. Okay, now ask yourself this. What is it going to take to eliminate the y from the middle and the bottom one? Let's multiply the middle one by a value of negative 2. Good. That gives me this. Negative 2x minus 2y minus 4z is negative, what is that, 34? Right? 2 17s are 34. That's good. Let's rewrite the bottom equation. I just have x plus 2y plus z is worth 16. Beautiful. Let's add this up together. Negative 2x plus an x, how much is that? That's a negative x. The y's go away. That's wonderful. Minus, was that 3z? Is worth, what's negative 34 and 16? How much is that worth? Negative 18. Wonderful. Awesome. So now I know that I have a negative x minus a 3z is worth negative 18. Hey, what's the next step?
Then the x and the x cancel from the problem.
Oh, check that out, right? Check that out. This equation is already in an x and a z, so I'm going to go ahead and take it and plug it right underneath here. So if I rewrite that, I would have an x plus z is now equal to 8, and I suppose I don't need that box here anymore, huh? So I took the top equation and moved it down. Yeah. Okay, great. So now I'm going to keep adding up. So the x's go away, so I'm getting negative 2z is worth a negative 10. So dividing out by negative 2, I can see that now z is worth 5. Nice. Okay, if z is worth 5, I can start to back substitute, can't I? So check it out. I know that x plus 5 has to be 8, so x has to be 3. And I got that from the top equation. So now all I need is the y. So I think I'll use the middle equation, since that one already has a y in there. So x is worth 3, so I'm going to have 3 plus y plus 2 times 5 has to be 17. That's from the middle equation. So looks like y plus 10 and 3 is 13 has to equal 17. Well, y's got to be 4. Awesome. So the ordered triple that I have found for this one is 3, 4, 5. Look at that, 3, 4, 5. A 3, 4, 5 triangle. And there's the problem start to finish right there.